Find the equation of the tangent line to this curve at t equals to pi over 3. Well, first recall that to get a line equation, you need the point and the direction vector. Since I want this line to be meeting this graph at t equals to pi over 3, if I plug in pi over 3, I would get a point on the graph which will be used as a point on the line as well, because they meet. Okay, so you have 3 times sine 4 pi over 3, 3 times cosine 4 pi over 3, and 12 times pi over 3, which is sine 4 pi over 3, let's see, the unit circle, 4 pi over 3 is here, and sine would be negative radical 3 over 2, so it would be negative 3 radical 3 over 2. Okay, hopefully you have these memorized. Cosine 4 pi over 3 would be negative 1/2, so it's negative 3 over 2. And 12 divided by 3 would be 4, so you get 4 pi. Okay, so that's a point on the line. That's what I want. Okay, now for the direction. So here's the idea. This RT is some kind of a curve, and actually it's a helix. You don't have to know it's a helix, but it is a helix, so it's something that goes like that. And at some point I want a line that's tangent to it. And right now I know the point, exactly which point this point is, but I also need to know what's the direction of the line, so it's tangent. And the idea for this is that if you differentiate RT, then you get the velocity vector. Velocity vector is the derivative of the position vector. And because velocity is always tangential to the movement, you can use v as the tangent vector once you find the r prime t, and if you evaluate r prime t at pi over 3, you get the velocity vector at pi over 3, which then you can use as the direction vector. Okay, so let's differentiate this. Sine 4t differentiates to cosine 4t, but because of the chain rule, 4 comes out. 4 times 3 would be 12. Same deal here. Cosine differentiates to negative sine, and differentiating 12t gives you 12. So when you evaluate v at pi over 3, you get 12 times cosine 4 pi over 3 minus 12 times sine 4 pi over 3 and 12. And we just got the values. Cosine is negative 1/2, so negative 1/2 times 12 would be negative 6. Sine is negative radical 3 over 2, so negative negative will be positive. 12 divided by 2 will be 6, so you get 6 radical 3 and then 12. So that's your direction vector. Okay, so how do you get the formula for that? Then xyz would be the, let's say these are the coordinate functions for the particle moving on this line. It will begin at this point, negative 3 radical 3 over 2 minus 3 over 2 and 4 pi, and then it's going to move according to t of this negative 6, 6 radical 3, and 12. Okay. Now if you multiply t to every one of them and add, this would be equivalent to the parametric equation, which is x would be negative 3 radical 3 over 2 minus 6t, and then y would be negative 3 over 2 plus 6 radical 3t, and then finally z would be 4 pi plus 12t. So that's the parametric form of the line equation. You can also solve this for t and write down a symmetric form also, but since the question doesn't ask which format it wants, this will be fine enough.